So here we got a parallelogram. We've got some proportions. AB to BP is 2 to 1. So that means that whatever this distance is there, AB is twice as long as B to P. And CQ to QB has a ratio of 1 to 3. That doesn't necessarily mean that these are the actual lengths. It might be that that length is 4 and that length is 2, but it's just proportionally that's what it has to be. So Q to B is 3 times longer than C to Q. Yes? A parallelogram, not necessarily, well, a rhombus is like if it's a square, then all these side lengths would have to be the same. A parallelogram is like a rectangle that you sit on and then it gets bent. Right? That's basically what's happening. And we got 2 of our vectors. And we can express everything in terms of A and B. So I'm going to give you guys head start. How did you do? Did you get negative A plus B for A to B? For A to P, if we know this is the fraction, does that make sense? You're going A to B 1.5 times, or 3 halves. So then you would have 3 halves negative A plus B, or negative 3 halves A plus 3 halves B. Now, if we wanted to go from O to P, we could go from O to A and then go from A to P, just using what we've already figured out. O to A is A plus, now in negative 3 halves A plus 3 halves B, negative 1/2 A plus 3 halves B. Now, what do you guys come up with for O to Q? Okay, so how did you, like, what was your initial strategy? We're starting here at O. You went to B. So you went from O to B. And then you went backwards to Q, from B to Q. Now, O to B is easy, right? Because that's just vector B. this, b to q, does it make sense that that's 3/4 of that whole length because of that proportion? So you're going backwards 3/4 of A. Now I'm going to see how I want to try O to P. I'm going to look on my original one here. I'm going to draw -1/2 of A like that backwards. And 3/2 B will be 1, that's B, and another 1/2 of B would be there. So I'm going to see if I start with this -1/2 A, and then, oh, those are joined. Whoa. Easy there. Okay, let's, oh, I lost my arrowhead. There we go. Whoa. Perfect. Just kind of neat that you can, I don't know if it works so well on your pieces of paper, if using tracing paper over top or something to draw it, but that you could get there using those vectors. And then part B now, we need to show that Q to P, so now we've got our new vector going from Q to P, that's 1/4 of the distance to A plus 1/2 of B. Well, since we found, and this is the nice thing about our position vectors, is once you find a position vector for a certain point, you can always go back to the origin. So we can go, here's our position vector for O to Q, and we make that negative. That gets us back to the origin. And then we can go from the origin to the point P. So one thing that can help us figure things out, you can think of -OQ is the same as going from Q to O. So we go from Q back to O, and then from O to P. And since we figured out all of these already in the previous part, just see what they are again. B minus 3/4 A. And O to P was -1/2 A plus 3/2 B. We're going to get 3/4 of A minus 1/2 of A. That'll be 1/4 A. We're going to get a -B plus 3/2 B, which will be 1/2 B.